Ever heard about the star that pulses like a heartbeat? I'm your galaxy guide, and we're going to talk about cepheid variables. There are these incredibly luminous stars called cepheid variables, and what makes them special is not their brightness, but the fact that their brightness changes over time. And this brightness can rise and fall at a very specific pattern, and that pattern can be anywhere between a day to 100 days. Here's the fascinating part. The pulsing is very important because it tells us something huge. Scientists discovered that the period of the pulse is directly related to how intrinsically luminous the star truly is. Meaning, if we can see the rate of the pulsing of the star, we can also tell how big and bright the star is. So now you know how bright an object is, and from Earth you can also see how dim it is, which means that you can also understand the distance this object is away from Earth. So they're actually called standard candles, and a good way to describe this is imagine you're holding a candle and it's just an arm's length away from you. But now you imagine you put that same candle across the room from you. You can see how the light dims despite the candle being exactly the same. So the same logic just applies here, but in space. So these stars are a powerful tool when it comes to measuring cosmic distances. This all became to be because of a woman scientist named Henrietta Leavitt. Early 1900s, while she was studying photographic plates, she realized that the longer the pulse, the brighter the star. And now this relationship is called the Leavitt law. Thanks to the cepheid variables, we have been able to measure how large the Milky Way is, distances to other galaxies. So it has provided a lot of help when it comes to cosmic distances, and that's why it's so important.